just a rough kind of walkthrough of those tools that we can use with matrices to help us with systems of equations. So the first couple of skills that you need for this objective is just taking a linear system of equations and rewriting it as an augmented matrix or vice versa. So let's say I've got a system of equations like this one here. Let's see, I'm going to be talking and writing as I talk. Okay, so here I've got this system of equations. Oh, that's pretty ugly, but it is what it is. And I want to put it into an augmented matrix. And we talked a little bit about this last time when I showed you how to use reduced row echelon form of a matrix to find the solution of a system. But I'm going to just review this because if we are wanting to put this in an augmented matrix, what we're going to need to do first is organize this thing. Notice that the variables are all in different areas, and we want them to be we want this to be an anal matrix, very organized, all right? We want all the x's to be in one column, all the y's in another column, and all the z's in another column, and all the constants on the other side of the equal sign. So the first thing we're going to do is organize this system so that that's the case. Notice that all my x's are here, all my y's are here, all my z's are here. Oh, look, all my equal signs are here, right? And all my constants are here. Well, we have it nice, neat, and organized. And then we're ready to put it into matrix form. Okay, notice I've got three equations. 1, 2, 3. That means I've got 3 rows. And I've got 1, 2, 3, 4 columns worth of data. Okay, and so we end up with a matrix that looks like this. Now, when we call it an augmented matrix, it kind of means that there's something added on to it. And that is just where we make this vertical line that separates the variable part of the matrix from the constants. Okay, and that's it. And so the next thing we would want to be able to do is go the other direction. Let's say I've got a matrix that looks like this, and I want to write it in linear form of a system of equations. Okay, well, based on what we just did, we should be able to use this kind of information up here, right? And identify what all these things are right here. Okay, so what are all these things? Well, we've got our constant here, right? Our equal sign here. Let's just go backwards. We've got z's, we got y's, we got x's, and we got w's. Now, if you wanted to choose different variables, a, b, c, d, fine, doesn't matter, okay? Just make sure that everything in one column has the same variable attached to them. It doesn't matter. All right, and so then we would just be able to write this. Let's write the first equation. Let's see, 1w, so just w minus x plus y plus z. And then we've got that vertical line, right? And that's going to be the equals 3 part. We don't have a w in this next row, so I can just leave that part out. I can just say I've got positive x minus 2y minus z is equal to 0. And the next one I can say I've got 2w. I don't have an x, but I've got plus 3y plus 4z is equal to 11. And then the last thing I've got is 5w plus x plus 2y plus 4z is equal to 6. And there you have it. That's a pretty easy skill to be able to convert back and forth between a matrix, an augmented matrix. And remember, this is augmented because we've got that vertical line that is got this little piece added onto it, right? And a linear system of equations.